Welcome to Tech Study YouTube channel. In this video, we'll learn a Java program which will use quick sort algorithm method to sort a set of integers. Here in this program, we are reading the inputs from a random number generator. Before going to see the program, let us see what is the logic behind this quicksort algorithm. Here in this quicksort algorithm technique, we'll consider first element of the array, that is input set, as a pivot element. So by using the pivot element, we'll partition the remaining set of elements in such a way that the pivot element will be in its sorted position and the elements to the left part of the pivot element will be the elements which are less than the pivot element, and the elements which are greater than the pivot element will be in the right side of the pivot element. Again, the same technique will be applied for the left part and then the right part of the pivot element. So at the end of the recursive quicksort algorithm, all the elements will be in sorted position. So once again I say that the first element will be considered as the pivot element. For remaining elements of the array, we'll apply a technique in such a way that after some position, the pivot element will be in its sorted position, where the elements less than the pivot element will be in the left side of the pivot element, and the elements which are greater than the pivot element will be in the right side of the pivot element, and pivot element will be in its sorted position. So let us see a visualization of this algorithm. Consider the element 14, 12, 16, 13, 11 and 15. So as I said, we'll consider 14 as the pivot element. We'll take two index, one is low, another one is high. We start comparing this pivot element from left to right until unless we'll find a element which is greater than this, and again we'll stop there and start comparing from right to left until unless we find an element which is less than the pivot element. If at that position we swap that greater element with the lesser element. So this will be continued until unless a sorted position for 14 will be found. That is, the sorted position of 14 will be this, followed with 12, 13, 11 will come to the left part, and then 16 and 15 will be come to right part. So the logic is we start comparing pivot element from low, that is left to right, until unless we find an element which is greater than the pivot element, and then we'll start comparing from right to left, that is 14 will be compared with 15, then 11, then 13, like that until unless we find an element which is less than the 14. So at some position the 14 will get its sorted position, then partition will be done. That is, the elements which are lesser than the 14 will be in the left part and the greater than the 14 will be in right part. So this is called the partition technique. Now for the remaining left part of the pivot element, again we'll apply the quicksort technique, and again for the right part we again apply the quicksort technique. We'll now type and execute the program by using gedit in a terminal. Type gedit quicksort sort.java. So as you know, import all the packages needed for program execution. Here we are using two packages. One is random, since we are generating our input using randomizer. Then one more is scanner package. We have a one class in the program, that is quicksort, which contain three methods. First one is public static void sort function, which take only one argument, that is integer array, the array of element which is to be sorted by using quicksort. In this function, we'll call quicksort method by passing three arguments, that is array of integers, its lower index, and then its higher index. As arguments. Then we'll write the definition for quicksort method. So parameter list is int array, int low, int high. So initialize all the things to the index variables. Int I is equal to low, j is equal to high. Take a temporary variable temp followed by one pivot element, that is int pivot is equal to array of low. Always pivot element points to the first element of the array. Now we'll do the partition. While I less than or equal to j, start comparing pivot element from left to right, that is array of I less than pivot element, increment I. So these two statements will do a task that it will start comparing from left to right until unless we find an element which is greater than the pivot element. Now in the same way, start comparing from right to left, that is array of j is greater than the pivot element, decrement j. While loops stops, will compare is I less than or equal to j. If so, we will swap the two elements. Array of I equal to array of j. Array of j is equal to 10. Now after swapping, increment I and then decrement j. Once we come out of this while loop, pivot element will be in its sorted position. Now we'll recursively apply quicksort for left part of the pivot element by passing array, low and j as arguments. Then same way again apply quicksort recursively for right part of the pivot element. I comma high. So this quicksort will sort the elements. Now we'll write the main method. Public static void main string arguments list. We'll declare a variable for scanner. Scanner SC is equal to new scanner system.in. We'll give a message that it is a quicksort program. We'll declare an index variable followed with system.out.println, giving a message, enter the number of elements to be sorted. We'll read it to a variable n. Int n is equal to sc dot next int. So we are using scanner object to read the input. Now, so what is our next task? We need input number of all the elements which are to be sorted, that we are generating by using random number generator and printing it. Random numbers generated are we use random class. Random r is equal to new random. Then we declare an array of integer to store the random numbers generated of size n. Use for loop to generate random number r dot next int of 10,000. So the element generated will be within the value of 10,000 and print to output. So for loop will generate n random numbers. N random numbers will be generated and that will be printed to the output. Next, since we need also to calculate the time needed for sorting, we'll declare a variable long and call system.nanotime to store the time where the execution started, and then call the sort function to sort array, followed by again one more variable in time to store the time at which the execution completed. Now we'll print the sorted array using a for loop again. Array of I followed by a space for each element. Then it's a print. Then print the time needed for execution of the program. Println the time taken to sort is, we'll calculate the time taken for sorting the elements by end time minus start time. Nanoseconds. We'll close the scanner by calling close function. So here is the program. Now we'll save and close the program. Now we compile using Java C. Then run the program using Java. I'll enter 6. So 6 random numbers are generated and it will be sorted, which will take 6,772 nanoseconds. If the same thing will be executed for only 3 elements, because the numbers generated are of greater values, it is taking more time, that is 8655 nanoseconds. Here is the output. So finally, thank you for seeing the program execution. So let us comment any questions or doubts regarding this program. Follow us on all the social media accounts. Thank you.